all that remains the same. Anything with 1, just add 1. The first rule of multiplication...
Okay, then where's the difference between addition and multiplication?
Well, multiplication is what? Exaggerated addition. Isn't it?
But isn't it a matter of mathematical convention?
What is?
If it was defined in the beginning, it could have been defined differently, but logical, it makes the most sense.
Use the mic, darling.
Sorry. Is it a matter of mathematical convention? If you define beforehand that something, logically, it makes the most sense that 1 times 1, if you have 1 laptop, 1 times a laptop is 1 laptop, that makes more sense than you say it's 2 laptops.
Well, now if you say...
And then that's where the mathematical convention comes in. And that's large part of math is convention. It's how it has been defined. It's a matter of definition.
And it's wonderful. The convention is all right if the material and the information being shared in the convention is true. But when you're talking about dogma being added in, with that thing that I showed you, did you look at the square root of 2? Do you think that that's a loop, that's a natural thing with the square root of 2? Did you believe that?
It's the same with pi. There's more mathematics.
No, it's not the same though. It's not the same with pi. What we just did, we multiplied it, we cubed the number, and then we divided it by 2, and we cubed it again and divided it by 2, and we did that a number of times, and that number still remained the same exact number, which we know cannot happen. It's right there, and that's what they say is the difference between, that's what they say allows 1 times 1 to equal 1, because 1, 1.414213562373095 ... is the square root of 2. But we know that that's not the case because it's illogical. That loop makes it invalid.
I'm afraid that is all we have time for. So please join me in thanking Brian Tarr.